So I'm going to be talking about building a Kubernetes operator from scratch and going into a little bit of detail on how we use them at Civo. So a little bit about me. I'm Director of Innovation at Civo, and as Andy's already mentioned and Kai's mentioned, I've been architecting the new Civo Stack platform and getting that out. I've been working on the platform for about 1.5 years now. And then going forward, I'll be looking at bringing new technology to Civo. So I think we've got GPU service coming up around the corner. So I'm working heavily on that at the moment, but it's always looking at new cool things and trying to get them into Civo. Outside of that, you can probably find me running my dog at agility, trying to teach my new son some new skills. He might be a bit young for painting, but I'm always teaching people something. And eventually we're looking to go back on holiday, which would be nice. So operators, what are they? They're basically software that runs within Kubernetes, and it's talking directly to the Kubernetes API. So rather than your application, say you've got an Nginx web server that you're serving data out to customers, an operator is solely used to manage and create objects that then serve things out to your customers. And it works on a model of eventual consistency, as does all of Kubernetes. I just wanted to touch on this on a little bit because eventual consistency is a really difficult thing to get your head around when you first start working with operators. We're used in the coding world to, you write some code, it runs and it does everything there and then, and it returns you a result of yes, everything worked, or no, there was a problem. With eventual consistency, what Kubernetes and your operator is guaranteeing is that at some point in the future, I will get your objects into a state that is what you've asked for. Now that could be straight away if the operator's not busy, or if it's not running for some reason, that could happen half an hour later. And the main way that the sort of Kubernetes and operators let you know about that is using the status field. So if you've ever looked at the status of a pod or a deployment inside Kubernetes, that's the contract effectively between Kubernetes and you to say that the pod is ready or the deployment is ready. Kind of a life cycle of how this works is, if you're a user down at the bottom there and you create an object and you store that in the Kubernetes API, the Kubernetes API will let your operator know that an object has been created. And this is kind of where that eventual consistency starts to come in, because Kubernetes doesn't guarantee that it will happen immediately. But if the Kubernetes API is busy or your operator is offline, it will eventually send that create to the operator. Your operator then runs a reconcile loop, and then it might go and create some new objects back into Kubernetes. Then if those objects that have been created at some point get deleted, or if the state changes for a pod, for example, to go from creating to running, Kubernetes will let your operator know again that that's happened, and you can make some more changes to the objects or other objects in the API. So when to use an operator, usually you don't need to use one. If you can get away of running something as a stateful set, or if you can run it as a deployment and use something like health checks to make sure that everything's fine, 100% recommend doing that, because operators are difficult. But if you do have a state model of how you want a variety of things like, say, pods or deployments and services all to mesh together, and you need to be making state changes on that, then an operator is the way to go. The other thing as well is if your application cannot be monitored by a health check. So if you're thinking like clustered databases, where you can't just delete a pod and then, you can't delete a stateful set object and then allow Kubernetes with health checks to move on to the next one and carry on. What you want to do is wait for your new stateful set object to come back in. It will then need to resync with the other pods in the stateful set and download data, and then you can move on to the next one. So when you've got, again, these more complicated operations, more complicated state that you need to manage, you're probably looking at an operator. One of the other key things is when you've got more than one type of your application, I've called it, to be deployed. So in the database example, if you want to be managing 10, 20 databases inside your single Kubernetes deployment, then you should consider looking at an operator. The other thing that I need to stress again is time to continuously upgrade operators. Something we've found is that Kubernetes is having a release every 6 months, and they're constantly depreciating features, adding new features. They're making changes to the specs. So, for example, apps v1, pods moved from beta to v1. And if you've got an operator that's creating old style objects, you're going to have to take the time to upgrade your operator and get the new version of things rolling out. So Civo have taken the decision to make an operator, and as Andy said, we deploy about 10 operators because we feel we've hit those criteria of where we're managing multiple objects of multiple states. So and as an example, we're looking at managing IP addresses, so public IP addresses that are attached to clusters. We've got a more complicated networking stack where customers can do firewalls, you can do custom routing. You've got the virtual machines themselves, and then groups of virtual machines are grouped together into Kubernetes clusters. All of our operators generally are talking to all of our other operators. So if you take a Kubernetes cluster, it launches virtual machines, and then it manages the states of those virtual machines. Those virtual machines are actually handled by KubeVirt, which are pods underneath the hood. Then going back to the Kubernetes cluster, it's got a public IP address. So that is, again, another object that we need to handle, we need to allocate, we need to hand back to the pool. And on the networking side, we need to make sure that that IP address is available to the virtual machines as they move around our supercluster. And one of the other things as well is that we're looking at doing operations on our objects themselves. So through civo.com, you can click a rebuild button on either on a node, and that will send an operation to our K3's operator, which will then do a rebuild of a node, which again goes down to a virtual machine and the underlying storage. The other thing is reboots as well, is another operation that's not a standard delete pod and hope that it comes back. We need to be a bit more state aware of what a VM, of how the VM is when it does a reboot. Does it come back up? Are there any problems during boot? So this is what I was talking about a more complicated state model, which is leading us down the operator route. So for the demo, I'm going to be live coding the demo completely. So hopefully I've sacrificed enough to the demo gods that it all goes well, but we will see how it goes. So be starting off using Kubebuilder and have a completely blank folder, get that up and running. I'll be creating a custom resource, running this against one of the Kubernetes clusters that I deployed out to Civo. And then I'll just be creating a single resource that's managed by the custom resource. So the idea here is I'm going to be creating a demo volume, which will have a size and a name. And then to explain the status field as well, what we'll do is we'll copy paste the name in the operator from the spec to the status field. And the second thing we'll add is functionality where the demo volume creates a PVC within our Civo Kubernetes cluster of the right size that matches the spec. And if that all works, I'll be very, very happy. So hopefully we have got, Kai, you've got VS Code up at the moment. Excellent. So again, going on the demo gods be kind, I created this cluster 20 minutes ago in Civo. So just showing you that that is up there. And I've got an empty folder here for the demo to be running. First thing that I'm going to do is just initialize Kubebuilder and initialize the project. So this is called scaffolding. And what Kubebuilder will do is it will go and create a whole set of files up here that are the base of your project. So it includes some of the Go modules that we'll need by default. Just because Kubebuilder needs to be in a blank folder when it starts, what I'm going to do is I'm just going to grab the kube config for my for the new cluster, and I'll just make sure that both of these shells are connected to the right cluster. Cool. Yeah. So they're both just getting nodes, and they are 18 minutes old. first thing that I'm going to go and do is create the create the custom resource for the demo volume. What I'll do, just to make it easy to show you the changes through everything, I'll just start a little Git repo. Put first commit in.
Dinesh, any chance you could zoom in your terminal and yes, thank you.
Yeah, that's all right. I'll put that down there for now. Is that better?
You went up one notch, didn't you?
I did. Do you want another
one?
Go
up one more, just nice.
Excellent. So yeah, the first thing I'm going to do is create the custom resource. So we'll just let that go through. I'm going to create the resource and the controller. So that's gone through. It's modified a few files. It's added some more Go modules that we need. It's then gone through and created this API folder, config folder, and our controllers folder. So just drop that down. In our API folder up here, it's created our demo volume type here, and it's put in a sample, just foo string, and in the spec area of the operator, of the custom resource. First thing that I'll do is, we don't want this called foo, we want it called name. And we also wanted a size field, and that one needs to be an int. So what this will do is it will create that custom resource, currently now with a spec section just containing a name and a size. We've then got this other structure down here for the status. So we'll just copy the name from the spec to the status. What Kubebuilder then does in the make file, if we just run a make generate in here, this will go ahead and take our Go code and our Go structures, and it will turn it into a custom resource definition here, which is what you can load directly into Kubernetes. So that's the webhook, isn't it? Generate. Make manifests. There we go. Make manifests. So this is the custom resource definition that we can load directly into Kubernetes. So we've got a spec section in here, which has got an integer of type integer. I have to have a look at that, a name of type string. So what I've probably gone and done here is, yeah, I've not named that correctly.
Yeah, in fact, Ali just posted that in the chat as well. Go like, that should be size. Thanks, Ali.
So now if we go back to this one, here you can see that size has now been, or this second property has been renamed to size, and it's of type integer. So this is showing that every time you make a change to your type in your Go code, what Kubebuilder does is it gives us the ability to just generate the Kubernetes stuff for free. And that's really, really handy, because as a developer, all you're doing is focusing on functionality, and all of that boilerplate YAML stuff is what Kubebuilder is giving us for free. So the other thing that Kubebuilder scaffolded for us is the controller. It looks like it's quite long, but realistically, it's only this section down here that we need to be worried about. So that reconcile loop that I was talking about earlier, all of your code happens in here, and all of the information about what is being reconciled is in this request object here. What I'll do, just to get us up and running, is I will just change this to log out that we have entered reconcile, and we'll just put the request out here to debug. So we come back to the terminal. What I can do is just run make install, and what this will do is it will install our custom resources into the Kubernetes cluster. So it's just downloading customize to help generate the custom resources. And here we can see that it has loaded that demo volume custom resource definition into our cluster. So if I get custom resource definitions in the cluster, we can see that demo volumes is there and it's only just been created. Obviously UTC versus BTC times here are an hour out. The other thing that Kubebuilder gives us is a sample demo volume, samples demo volume here, which allows us to easily create an object that people can use to work with in the cluster. I did say I was live coding this, so I will try and talk and code at the same time. What I'll do is I'm in the default namespace. So I'll just apply sample. So that object that we have there is now created. If I get demo volumes, we can see that that's been created and it's got the same YAML spec here of the name, demo, and size 10 that we've created up here. So nothing's actually listening for this custom resource yet. So that's what the code in the controller is there for. That's what's going to be connecting to the Kubernetes API and listening for that demo volume or being notified about that demo volume. And then it will do stuff based on it. So again, Kubebuilder scaffolds us up a makefile that we can just run make run against. What that will do is it will connect to the Kubernetes cluster, and it should, here we go, output here that it's reconciled against our request, which is default/demo volume sample. Again, this isn't very interesting, but it just shows that you don't need a huge amount to start getting your controller up and running. First thing that I'll do, again, some more boilerplate code, is copy that, I'll leave that in there, is copy the name from the spec to the status field. And this is filling out that contract between your operator and the rest of the world. So let's firstly load that volume object up. My volume. Name, namespace, namespace. Loading that into volume. We could do error handling here, but I'm not going to. I'll live on the edge. If you were doing this for live, then yeah, definitely look at adding error correction in here. Just log this out as well. So we've got that. So what we're going to do is we're going to check whether or not the volume.name spec.name equals volume status name. But we're going to check if they're not equal. So if they're not equal, what we're going to do is set that. So volume status name is going to equal volume spec name. And then we're just going to send we're just going to save this back directly to the API. So status update. And we're sending the context and the volume itself that we're going to update. So let's rerun that. Everything looks green, so hopefully it will run. Excellent. Let's see if I can explain the output here. So our operators started up here. This is everything around startup, all the way down into here. Then this is our first reconcile starting up here. And we can see that it's going through, it's grabbing out the demo volume and outputting it there. We are then doing that save, and because of the way that that reconcile works, is that next time the as soon as the demo volume is updated, another reconcile will be called on that same object, which is what we're seeing down here. What I probably should have done was added a bit more output to this. So let's just delete that again. Just put out the volume spec here. The status here. Delete that for now. Delete that object, because what's happened at the moment is that the status has been updated, so this little demo won't work, but I will recreate that and we'll run our operator. So this time, here we go, we can see a little bit easier that the spec here named demo and size 10, and the status is being left empty. If we put in our code back to do that copy through, just clear that out and do a make run again. So we can see that the first time that we're reconciling again, the status is empty. We're then recognizing that in the code. We're rerunning that reconcile loop after it. Sorry, we're noticing that this status is wrong. We are updating it, and then we're re-reconciling so that next time we load up, we've got the name and size set, and this time the status is set. What happens is we're not now making a change, so then we stop reconciling here, and this object is considered done. So that's not overly interesting because we're just kind of copying data around. The next thing that I'm going to do is use this to create a PVC in the cluster of that 10 gig size. So just come up here. I like to out of the way. Let's create a new function against that object to reconcile PVC. We'll send in the context, the demo volume, and we'll send in the log as well, the logger. Return an error. Just got that running. I'm happy. We'll return nil. Just got some code that I'm going to copy paste out of here because this is a little bit fiddly to get sorted. And then I will explain what this is doing. It's not the right object. So because of that eventual consistency, we don't know when that this reconcile function is going to be run, and it will be run on startup as well. So the first thing that we're going to do is we're going to get a PVC out of the cluster with the same name as our demo volume. If we've found it, we're just going to exit out because as far as we're concerned, everything is right and we're exiting. If there's any other error connecting to Kubernetes, we'll just exit out here and let everything re-reconcile. And what we're doing down here is we're just going to log that the PVC has not been found, and we're going to go through and create the PVC. This is all a little bit fiddly because of the way that these objects are defined, things like resource quantity and things. But if you look at the documentation for the client Go libraries, it's all explained in there. Let's just check these because I think that's the right errors package. I do have an error. Just grab that from my sample code. Definitely live coding. Grab the whole import section from here. That should hopefully fix everything. I think it's because this is I think it's just missing some Go mods because it's the first time that I'm running this. So we'll just use the helpful Go error messages to get them added in. And that should be it. Cool, everything's all green and happy. So I'm missing a couple of lines down here. So we've created the object ready to be created. And what we'll do now is we'll just actually create it with Kubernetes. Just wondering how I'm going to do this with a big console. Let's get all of the PVCs in that namespace. I'll leave this operator log quite small for now, but if everything goes correctly, what we should see is the operator startup. It will get a reconcile request for that demo volume, and it won't do anything because while I've written this method, I've never called it. So let's actually call it and try that again. What we should see this time is that the PVC, there we go, gets created, gets requested. It will have a capacity set hopefully correctly. And this is actually, because it's in Civo Kubernetes, it is using the same CSI driver that Andy was talking about earlier. And there we go, it's been bound and it is ready to go. So that is everything for the demo. So hopefully if I can bring Keynote back. I think that went as well as I would have expected. So I just wanted to go into some of the lessons learned that Civo have had from writing operators. Start with eventual consistency, taking some time to get used to. This idea of you creating a contract between your code and Kubernetes and your code having to abide by that contract, especially when you're talking about other operators, it takes a lot of time to get used to. Operators are complicated. We've learned a hell of a lot. There's not a huge amount of information out there about how to write operators, some of the best practices to use. But if you are looking at writing operators, feel free to reach out to us on the community Slack. Alejandro, myself, Alex will definitely reach out and help you. One of the things that I didn't cover in the demo is about exiting early. So as soon as you make any change to any object, be that your custom resource or the other things like pods and deployments in Kubernetes, as soon as you make any change, you want to exit out and let the re-reconcile loop handle another reconcile. It's really, really important because you're working on this delayed set of information within Kubernetes. Exiting early and just letting a re-reconcile happen is really important. That status field is not for you as the operator writer. That's your contract and your fulfillments with the rest of the world. So don't make assumptions on the status field and go, oh, the status field says that the PVC is of size 10. I'm just going to carry on and ignore it. What you want to be doing is getting the PVC out of Kubernetes and checking whether or not the size is 10. If it's not, you either update the status field or you set the size to 10 correctly in the PVC. And the last thing is that eventual consistency still takes some time to get used to. Maybe I did that twice, I don't know.
At least it's there now.
Just some links here. We can get these out as well on there. The Kubebuilder book is really good. The GitHub repo as well is really good. There is an operator white paper as well that's being under development at the moment. Alex Jones is helping with that. And Operator SDK is one of the other projects in line with Kubebuilder as well. So we'll get links to all of these out after the talk.